Box contains 2 red, 4 green, 6 black, and 3 blue. How many ways can a sample of 4 be selected if exactly 3 of the balls are the same color? Well, if you look at this, we're looking for part A, 3 red and 1 other, 3 green and 1 other, 3 black and 1 other, and 3 blue and 1 other. Now we know that this one can't happen because we only started off with 2 red to begin with. So we're looking at the other 3 cases. So 3 green and 1 other, so it's a combination. 4 choose 3 times of the remaining, 6 and 3 is 9, 10, 11. We need 1. Of the black, we need 3 of those. 3 and 4, 7, 8, 9. So the remaining 9, we need 1. And for the 3 blue, well, 3 choose 3. And of the remaining 12, we need 1. Part B says exactly 1 red and at least 1 green is drawn. So we can do red, green, and other. We want exactly 1 red and at least 1 green. At least 1 green means 1 or more. So if we wrote it out as a chart, notice 1 red, 1 green, 2 others, 1 red, 2 green, 1 other, and so forth. So this would be the combination. Now there are, let's write this up here, 2 red, 4 green, and the others, 6 and 3 is 9. So when I write this out, this is 2 choose 1 times combination 4 choose 1 times the combination 9 choose 2. That gets me 1 red, 1 green, and 2 others. Combination 2 choose 1 times the combination 4 choose 2 times the combination 9 choose 1, and then plus combination 2 choose 1 times the combination 4 choose 3. Part C, at most 2 blue balls are drawn. At most means 2 or less. So if we look at this, what do we want for this problem? We want 2, 1, or 0. We don't want all 3 blue. So if we do this by total minus what we don't want, then this is the combination. Well, pick any 4 objects. So we have 10, 13, 15 objects. Pick 4. Minus what we don't want all 3 blue, which if we come back up here is this last case right here. And that gets me all 3 blue. Now we could have also looked at this and drawn it directly. In other words, if we did this directly as 2 blue, 1 blue, or 0 blue, we'd have what we're looking for. So we could have also done the combination 3 choose 2 times the combination 12 choose 2 plus the combination 3 choose 1 times the combination 12 choose 3 plus the combination 3 choose 0 times the combination 12 choose 4. Both methods give us the same answer, just depending on which one you want to write down, or plugging the calculator is deciding which one is the easiest. Part D says there's more red than green. Now we have red, green, and other. And from above we know there were 2 red started, 4 green, and then 9 others. And I want more red than green. So 1 red, 0 green, and we need 3 others. 2 red, 0 green, and 2 others. 2 red, 1 green, and 1 other. So these are all of the options we have. So now it's combination 2 choose 1 times combination 9 choose 3 plus the combination 2 choose 2 times the combination 9 choose 2 plus the combination 2 choose 2, 4 choose 1, and 9 choose 1. Ten cards will be selected from a deck of 52 cards. How many ways can this be done if we get at least 2 spades? Well, at least 2 spades means 2, 3, 4, 5, all the way up to 10 spades. That's a lot of things to count directly. So one thing we want to realize is that for this problem we don't want 0 or 1 spade. So the easiest way to count part A is total minus what I don't want. Total is selecting any 10 cards from the deck, so it's a combination 52 choose 10 minus what I don't want. Now there's 2 different cases for don't want, so I'll put a big bracket here. 0 spades. For the 13 spades, pick 0. Of the remaining cards in the deck, remember there's 13 of each suit. We have spades, hearts, diamonds, and clubs. So for the diamonds, hearts, and clubs, there are 39 of those cards. We need 10. So that gives me the card hands that have 0 spades. Then we do 1 spade, which means I have to have for the remaining 39 cards 9 other cards. So there's part A. Now part B, it says at least 3 spades. Well, at least 3 spades in part B is saying I want all of these, which basically means that this one right here gets added to the don't want pile. So from the same strategy, 52 choose 10 is the total. Now what I don't want is 0, 1, or 2 spades. 13 choose 0 times 39 choose 10. There's 0 spades. There's 1 spade. And there's 2 spades. So notice each one of these is a category. Now if I didn't want the brackets, remember distribute the minus sign across, in other words change all these pluses to a minus, and you'd have the same answer. A box contains 12 red, 8 green, and 20 blue. How many different samples of 8 marbles may be selected if at least 3 are green? So at least 3 green means 3, 4, 5, 6, 7, or 8 green. Now noticing that's 1, 2, 3, 4, 5, 6 things to count. A lot of things to be writing down. So ask ourselves, well, what don't we want? 0, 1, or 2 green. So, much easier, shorter list. So, I'll do total minus what I don't want. So, total is, pick out any 8. Now we have 20, 8, and 12 more makes 40 of these objects. There's the total. Now, minus what I don't want. 0 green. That means from the other 32, I need 8. Or 1 green. Or 2 green. Part B says, well, how many ways can I get a sample 8 that all are to be green? Well, I have 8 green. I need 8 of them to select. And if you think about combination 8 choose 8 is 1. Question 18. 9 people are to travel to dinner in a 5-seater van and a 4-seater sports car. How many different groups of 5 and 4 are possible for the trip? So in other words, we want to separate to ride in the vehicles. We're not concerned about who's driving, who's sitting up front, or who's sitting in what seats. It's just separated into 2 groups. So first of all, if you think for the group of 5, in other words for the van, I had 9 people, I need 5. And the remaining people, there's 4 of them, they have to go in the sports car. Now we can't have repeats because you can't have the same person in some place twice, or the same person in both vehicles. Now, I filled the van first this time. I could have filled the sports car first, in other words, the group of 4. 9 choose 4. And then the 5 remaining, I need 5 of them to go in the van. So both of these are the same result. Now part B, how many different seating arrangements, now we're concerned about who's sitting where, are possible if 2 people, Juanita and Kareem, are the designated drivers. So if we look at this, we have 1, 2, 3, 4, 5. There's our van. 1, 2, 3, 4. So there are the 2 vehicles. Now I'm going to specify one of the seats, my choice. Those seats I've underlined in blue are the drivers. And we have 2 people that can drive. So for this first driver's seat, I have 2 choices. For the next one, I have 1 choice. Now for the remaining people, I don't have any restrictions. So we had 9 people, 2 of them already situated. That means 7 choices for that seat, and then 6, 5, and 4, and then 3, 2, 1.